So now, here we have a circuit. There's about 10 milliamps of current flowing through this circuit, as illustrated right there. We can't really tell that other than looking at the power supply. About 10 milliamps of current right there. 10 milliamps is the same as 0.01 amps. Always be aware of that. And just in case I miswired something, I limited the power supply to 20 milliamps of current. Now, next to the schematic diagram that I showed there, this is the circuit we got. Now, right now on the board, we have basically the same circuit right there, but instead of just a direct connection to ground, which is passing about 10 milliamps of current, we can add an LED. So it doesn't matter what color the LED is right there, as long as, you know, it only needs like 2 or 3 volts to conduct. We're going to take the green LED right there. It needs about 3 volts to conduct, but there we go. It is lit up pretty bright right there because there's about 10 milliamps of current flowing through it. Red LEDs don't need as much current. But yeah, there you can see power supply, again, is providing about 10 milliamps of current. Now, it's not always providing 10 milliamps current if we don't have a path to ground that is from collector to emitter. That is where the 10 milliamps of current is. Now we remove that. So there is a little bit of current that will flow elsewhere in the circuit, but it's probably less than 1 milliamp of current right there, as you can see. So now we'll look at this in more detail. We have a PNP bipolar junction transistor right there. Starts with 2N. It's a 2N3906 I'm using. If you use a different transistor that doesn't start with 2N, it will likely have a different pin layout. But in any case, left pin emitter, middle pin base, right pin collector. I want to put the emitter on top, so I'll just swivel it that way, right there. Emitter's on top, and we will plug it in. So we are going to use the transistor as a current source. So when a bipolar junction transistor is a current source, you need resistance between the emitter and the positive supply right here. We're using 5 volts. So 100 ohm resistors are going to make the math easy. If we put 1 volt across 100 ohms, that's 1 volt divided by 100 ohms equals 0.01 amps of current, which is 10 milliamps of current. I have the power supply shut off right now, and we're not done wiring, so no current right now. So now we come to the base. The emitter will have the base voltage, but it'll be about 0.7 volts higher, approximately 0.6, 0.7 in any case. So we're going to take a pull down resistor to begin with. It's just going to give us a current path for the red LED that I'm going to use. But right now, that would basically turn the transistor on, and we get more than 10 milliamps of current flowing. We don't want that. We're going to take a red LED right here. So long lead the anode towards the positive supply, short lead the cathode to the base. As you can see, I got the yellow jumper there to the positive supply. So that's where the long lead the anode's going to go. Short lead the cathode's going to go down one spot. So now current's going to flow through the LED and the resistor right there. And that's going to raise the voltage at the base. So the way it's going to raise it is we got 5 volts there. And it's about 1.7 volts approximately to get the LED to start flowing, leaving about 3.3 volts across the 10K resistor right there. But the emitter is interested in the base voltage in relationship to the positive supply right there. So we got 5 volts there. If we got 3.3 volts at the base right there, that means this is going to be about 0.7 volts higher right there. So about 4 volts at this point right there. So 5 volts and 4 volts is the difference of 1 volt. That's how we're setting 1 volt across the 100 ohm resistor. So it's that simple right there. Now, doesn't matter if we have a direct connection to ground or if there's an LED along the way right there. We do need them though to get the current to flow. I'll zoom back right here. Turn the power on, and you can see there's no current now because there's no path to ground. There's, you know, current's not actually going through the LED, it's going through the 100 ohm resistor and the 10K resistor. But now, when I plug this in, now the current going through the 100 ohm resistor gets sucked to ground right there pretty easily. So, I mean, there is a little bit of current going through the red LED, just enough to build up a little bit of voltage, probably a little less than 1.7 volts, probably about 0.6. But there you can see we got about 10 milliamps current. So yeah, now we'll zoom in. Doesn't matter if we do the red LED or the green LED. They have different forward voltages. So often that changes how much current flows, but we already set a voltage across the resistor. The LED is not setting the voltage as long as we have enough supply voltage. So we need, in this case, 3 volts to light the green LED right there. The resistor's got 1 volt across it, and therefore right now the transistor's got 1 volt across it. When we had the red LED there, it needed about 2 volts across it, and therefore the transistor had about 2 volts across it. It takes away voltage from the load. So now, that was the main thing we talked about, was voltages. Even though it's a current circuit, it's all due to the voltages that we set. So we'll actually measure that. This meter, I just have to set it to V for voltage. It's already set to DC. Otherwise, I'd have to hit select if it said AC to DC. And all of our measurements, I think, are going to be in relationship to ground for the most part. We'll plug that in, and I thought about touching everything with the probe there, but probably better to use the jumper right here. So as I said before, we're going to have about 1.7 volts because of the red LED, less than 5 volts down here. So about 3.3 volts. Not going to be exact, but it's going to be close. There you can see about 3.3 volts approximately. And so that's the voltage across the resistor. If I want to measure the voltage across the LED, which looks like it's probably a little bit more than 1.7 right there, we can do that as well. There you can see that. Now, let's go to that resistor. As I said before, it's got about 1 volt across it. It's a 100 ohm resistor. It's at the emitter, so it's setting the current approximately 1 volt right there. Pretty straightforward. Now, we can also go to the base. So that's 1 volt less than 5 volts. So it'll be about 4 volts. But we'll go down to the base. It's going to be about 1.7 volts less. So there you can see we got that difference. That's from the positive supply right there. So red LED's got about 1 volt across it. Emitter to base, about 0.7 volts across it. If I come to ground, we're going to see the opposite voltage going the opposite way right there. Somewhere around about 3.3 volts or so. I don't think I showed that earlier. So yeah, I think we looked at all the voltages. We have this jumper going to ground right now. I'm going to open the circuit, and now current's not flowing. So current is flowing through the 100 ohm resistor and the 10K resistor, but it's taken away the voltage that would have gone across the LED right there. So it's not lit up. We are going to measure current. So I want to get this where it's not measuring anything. You don't want to accidentally be measuring something when you set the meter to measure current. Now, what we have to do is bridge the gap. So come right to the jumper, and so we don't have any current on there because that's not where I wanted to go. There we go. I want to go there. Now I want to go to the collector. That's what I did wrong. So about 10 milliamps of current right there. And again, doesn't matter that that's a bad spot right there, I'm pretty sure. I didn't really need to move the blue jumper because we're going from the collector directly to the negative supply, whether it's through 1 jumper or 2 jumpers. Didn't really matter right there. So let's do the LED next. So I can take whatever, red one, green one, doesn't matter, right there. And now I move this down 1 spot right there. So again, we don't have to go through that jumper because it's going through the meter right there. Well, we measure it, and the meter is going to the negative supply right there. So yeah, we got the same current right there, red LED. Pretty straightforward. And then green LED as well. We will get, there we go, got to go up there. Same exact amount of current. It's a current source, so it might, shift just slightly or whatever. But for the most part, the current is set in stone. Now, we will, we just looked at the current being the same through all 3 of them. And again, be really careful when the meter is set to measure current. You don't want to accidentally measure the wrong thing. Voltage, you're pretty much always safe unless it's an extremely high voltage, accidentally measuring something when you didn't mean to take that measurement. It's safe for the meter voltage. The one problem you might have, this metal probe, you touch one part of the circuit with the probe and another part of the circuit with a different part of the probe, that could short out the circuit. If you're like sliding in between components or something. you might touch two spots you don't want directly connected together. But for the actual measurement, it's pretty much always safe for the meter to measure voltage, as long as the voltage isn't too high. So again, I mentioned earlier that we got the voltage across the transistor. So let's work our way backwards. Why not? So there's about 3 volts across the green LED, and it's kind of blinding me right now. It's really bright, but there you can see about 3 volts in relationship to ground right there. So the other end of the transistor is about 4 volts, but the voltage difference between the emitter and the collector is about 1 volt right there. So we got about 1 volt across the resistor, 1 volt across the transistor, and 3 volts across the LED for a total of about, that's the red jumper there, for a total of about 5 volts. Go to the positive supply right there, 5 volts. And really glad to get that out of the way because it's blinding me pretty bad. Now we got the red LED, much easier to look at. Probably shouldn't look at that either. It's directly, it's a bit bright. But in any case, it's got about 2 volts across it. I'm pretty sure this is a bad part of the board. I can plug it in there. So yeah, 2 volts across the red LED. Now, 4 volts total, but it was 1 volt across the transistor when we had the green LED. Now it's 2 volts, 4 volts total. And again, that's putting about 1 volt across the 100 ohm resistor in all of these cases right there. So now I'm going to remove it, and when I remove this jumper, you can see it goes haywire. We need that current going to ground in order to get us the that voltage build up right there. Right now, current can flow through that 10,000 ohm resistor from the emitter right there because the LED is not as letting current flow through as easily as the 100 ohm resistor. We need that suction down to ground right there with the transistor in order to get that. So again, we had about 1 volt across that. That's what I was going to do. It's going to remove the LED there and then just put ground. We haven't done that measurement yet right there for the voltage across the transistor when we go to ground. So kind of lost track of what I was doing. That's what I was doing. There we go. So we got our volt across the 100 ohm resistor. Again, it might change like a little bit as heat changes and stuff, but those are very small changes. At some point it's going to settle. And again, we got 5 volts total, because right now when I go to the collector, it's a direct connection to ground right there. So 1 volt across the resistor, about 4 volts approximately across the transistor, and that's how it's keeping that volt across the resistor. It's dropping about 4 volts, and I explained why earlier right there, even though it's probably confusing at first. Just look at a bunch of current source circuits and you'll start seeing how the voltage at certain points of the circuit being across a resistor right there sets current for other parts of the circuit. The other components along the way take up some of that voltage in some way or another, either as a load or as a control, which the transistor is right there. They're taking up some of the supply voltage, whatever the extra supply voltage is in comparison with the voltage across your current setting resistor. Hopefully that makes sense, but otherwise that's the end of this video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out links down below. They all help out a lot. I'll see you in the next video.